Welcome to lesson 3.5, proving triangles are congruent. Now, if you ever had a friend or a brother or sister or a parent who had taken geometry and they're like, man, I really wasn't good at that, it's because of proofs, which is exactly what we're doing in this lesson. Now, don't worry, I promise I'm going to teach this super well. It's going to be incredibly clear, but to do that, you need to memorize a few things. And if you memorize these things, this will be a piece of cake. So, what do you need to memorize? Well, these essential theorems in geometry, this is what we're going to refer back to a lot today. All right, so you have four right here: the vertical angle theorem, the reflexive property, the midpoint theorem, and the perpendicular angles theorem. These four theorems are essential to understand to make this lesson as easy as possible. So, I can't stress this enough. Memorize these four theorems, and today this lesson will be super clear for you. All right, so let's jump into it. Vertical angle theorem. The vertical angle theorem is this: vertical angles are always congruent. That is the theorem. Now, what is a vertical angle? That's a good question. Well, if two lines intersect, like we see here, so we have AE and it intersects with CD, the angles opposite each other, all right, the angles that are opposite each other, like we see right here, these are the vertical angles, all right? So angles that are opposite each other when two lines intersect are vertical angles. And it probably looks like that. This angle and this angle, they do look about the same. They're across from each other. All right? So I know that angle ABC, which is right here, ABC, remember the vertex always goes in the middle, and angle DBE, that's the angle right here, are vertical angles. And because they're vertical angles, I know angle ABC is congruent to angle DBE. All right, that is our first essential theorem. Vertical angles are always congruent. And remember, they're across from each other. You have to be able to identify them. Two is the reflexive property. Reflexive property is this: a side is always congruent to itself. Pretty straightforward. Let me show you how we'd use this. So we have two triangles here. We have this triangle right here, and we have this triangle right here. All right, we have two triangles. Now they share a side in the middle, right here. They share this side, YW. And since they share that side is congruent for both triangles, right? Because the side of this triangle is the same for both of them. So it's congruent for this triangle and it's congruent in this triangle. They are the same. So basically what this is, it's this. Two triangles share side YW. All right? They both share this side. So therefore, YW is congruent to YW. So when two triangles share a side, all right, that side is congruent to itself. Kind of makes sense, right? It's stupid to state, but a side is always congruent to itself. And we only use this if two triangles share a side. The third one is the midpoint theorem. All right? The midpoint theorem is a midpoint divides a line segment into two congruent segments. All right? So what does that look like? Well, let's look at this statement. E is the midpoint of AC. So this is E right here, and this is AC. All right. And what I know is that a midpoint divides a line into two congruent segments. So since this point is in the middle of AC, I know that this and this are congruent to each other. So AE is congruent to EC. And that makes sense, right? Because if E is directly in the middle, I know this part and this part must be exactly the same length, or else it wouldn't be in the middle, right? So AE is congruent to EC. That's my conclusion. All right? So if it's in the middle, it splits it into two congruent segments. And your final one is the perpendicular angle theorem. Perpendicular lines create 90-degree angles. You might remember this from the first unit. And all 90-degree angles are congruent. That's the key here. So let's look at this statement. OM which is this line right here, is perpendicular. You might remember that this is the perpendicular symbol. That's perpendicular to LN. All right, these two are perpendicular. So you might remember this. So when you draw perpendicular lines, you have to draw these right angles. So there's a right angle here and here. All right, it creates those right angles. Well, because these are both 90-degree angles, I know that angle LMO is congruent to angle OMN. And how do I know that? Well, they're both 90-degree angles. Since OM and LN are perpendicular, it creates these two 90-degree angles. And 90-degree angles are always congruent to each other. So angle OML is congruent to OMN. They are both 90 degrees. Both 90 degrees. Okay, so those are the 4 theorems that you need to know to make this lesson a piece of cake, okay? Review them. If you have to watch this again, do it. But these 4 will make this lesson a piece of cake. All right, let's move over to writing some proofs, huh? All right, so let's do a quick review of what we already learned. Side, 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 angle, side, and angle, and angle, angle, side. These are the 4 ways we learned how to prove triangles are congruent. And here's examples of each. Right? 3 sides are congruent in 2 triangles. A side, an angle, and a side with the angle in the middle are congruent. Angle, side, angle, and angle, angle, side. Which, by the way, is the same thing as side, angle, angle. Doesn't make a difference. All right? So if you did side, angle, angle, whatever. Okay? So, we're going to determine if the following angles are congruent. All right? And triangles are congruent. But we got to use a few of the things we learned in those essential theorems. So if we're looking at these 2 triangles, we have ABE and CBE, right? We have 2 triangles right here. And we only see that there's 2 sides congruent. But we just learned that if they share a side, as they do right here, then that side is congruent to itself. So we have a third side that's congruent. You see, if it shares a side, that side is congruent in both triangles. So now I have side, side, side congruence in these triangles. So I know triangle ABE is congruent to triangle CBE because of SSS. Okay? And that arrow just means because I don't have enough space. Maybe you could fit it in. All right, let's look at this one. Now you're looking at this and saying, okay, once again, we only have 2 sides that are congruent. We know FE is congruent to EM and GE is congruent to EP. Right? We have these congruent sides, but that's not enough information. Well, you might remember that vertical angles are always congruent. And vertical angles, or when you have lines that intersect, such as we have right here, we have this line that intersects with this line, and these 2 angles are cross to each other. So these 2 angles are vertical angles, so they're congruent. Well, now that we mark that, now we have side, angle, side congruence. So I know triangle FEG is congruent to triangle MEP because, and this is side, angle, side. 2 sides with the angle in the middle. All right, let's see if we're getting the hang of this. For this one, once again, we're looking at this. We have a side and we have 2 90-degree angles, so we know those 2 are congruent to each other because they're both 90. And these 2 share a side right here in the middle, right? We have 2 triangles that share a side in the middle, so we can mark that. Well, now what you have is an angle and 2 sides. But don't get tricked, all right? Because the angle is not in the middle, right? This is actually 2 sides with an angle on the outside. It has to be right here. And since it's not in the middle, right, this is side, side, angle, this is not congruent. They are not congruent. And I'll tell you why. This is angle, side, side, and that's because there's no ass in math. Get it? There's no ass, A-S-S, in math. That's really funny. No ass in math. I cracked myself up. Okay, let's keep going. These 2 triangles, right? Well, we have an angle and a side, but we need a third piece of information. Well, since these two angles are vertical angles, we can mark them, right? These are vertical angles. We have a cross right here. These two angles intersect, and they make these two angles, which are congruent to each other. And when I mark these vertical angles, and you should always mark vertical angles, well, now you have angle, side, angle, angle, side, angle. So now that I have that, I know that triangle YPO is congruent to triangle MPN because, please write because, I don't have enough room, of angle, side, angle, right? Angle, side, angle. Sides in the middle of the two angles, I know it's angle, side, angle. All right, let's try a little more practice. We have two triangles right here, and here. We can mark the side that they share. They both share this side, these two triangles. All right, so now I know, let's draw these out so it's a little clearer. Okay, we got our two triangles right here. I know that these two triangles are congruent, and I marked the share side because of angle, angle, side, right? There's two angles, the side's not in the middle, so I know that triangle FKN is congruent to triangle NKL because of angle, angle, side. And my last one, let's try it one more time. Once again, you should be getting used to this. If there's ever vertical angles, you got to mark it first, all right? These two angles are vertical. They're across from each other when two lines intersect. So now I have side, side, angle. The angle's not in between. So don't get tricked. This is not congruent. Why? Because there's no ass in math. Oh, gets me every time. All right, let's work on to proofs. All right, let's go on to proofs. Now this is the thing that your parents, your friends, everyone hated. All right, but I'm going to show you it's not that bad. All right, you got to follow these steps very clearly though. What happens is that you're given information, and then you have to prove that two triangles are congruent. So the first thing you do, sorry that changed. That was kind of like some movie magic right there. So the first thing you do is you take your given information and you mark whatever they give you. Okay, so given, all right, we know that Vx, which is right here, is congruent to xz. So Vx is congruent to xz. That's given to us. All right? And this is just following step one. We're marking our triangle. Step two, the second thing we know is that angle W is congruent to angle Y. So we mark that by just drawing our angle congruent marks. All right. We've marked our our given information. So you mark your given, and then if there's any other theorems you could apply to this that's not given but you know is always true, you can mark those. So in this case, we know that these angles are vertical angles, so we know that they're congruent. All right? Well, now we have enough information to actually prove that these triangles are congruent. It's angle, angle, side. But now we actually have to write a proof, and this is where people get caught up, all right? So just to go over, first thing you do is you mark a triangle with the given and any additional theorems that you can put in here, such as vertical and angle theorems, reflexive properties, all right? Now once it's marked, you have to write over here your actual proof, and we call this a T-chart proof. We're going to use exactly what we did before. You have one side that's evidence, right? And that's what we did last time. We just listed the things that we know are true. And the second side is how we know those things are true, all right? How we know this is true. How we know it's true, all right? So let's start with what we know how to do. We know how to mark what we know is congruent here, okay? So we know that Vx is congruent to xz, all right? Start by just marking down all the evidence like you've done before. We know that that angle W is congruent to angle Y. And finally, we know that angle, WXV is congruent to angle ZXY. And that's this angle right here. WXV is congruent to ZXY. All right? And that's all your evidence. We got the evidence. We know how to do that from the last lesson. Well, now we have to write how we know those things are true. Well, Vx is congruent to xz. Well, that was given to us. All right? If it's in the given information, you write given. All right? Angle W is congruent to angle Y. That was also given to us. All right? But this last part, that wasn't given to us. That was a theorem that we learned. Right? And the reason we knew that WXV was congruent to ZXY, well, that was because we know that vertical angles are always congruent. And you have to write that here. All right? You actually have to say the reason you knew that was true. And that's because vertical angles are always congruent. All right? Now that you got your three pieces of information, all right, the last thing you have to do is write your conclusion. And this is exactly what we did before. Nothing's changing here. So now you just write that triangle WXV, all right, and I'm just getting this from here. This is what we're proving, is congruent to ZYX. And why? Well, this is angle, side. And you just have to write that AAS, congruence. Okay? Simple. Okay? You write your evidence, how you know things, and then you write your conclusion. All right? You have to always write your conclusion. Conclusion has to go in there. All right, we're going to try it 2 more times. All right? I know this lesson's getting long, but buckle down. We're going to get good at this stuff. It's important. This is the backbone of your geometry right now. So, once again, you look at your given information, you mark your triangle, and then we'll write our proof. All right, and we're trying to prove that triangle ABD is congruent to CBD. Well, the first thing we know is that AC, which is right here, is perpendicular to BD, which is right here. All right, so since they're perpendicular, I can mark these 2 angles. Angle here, angle here. All right, the second thing I know is that D is the midpoint of AC. And remember, if something's the midpoint, then I know that this is congruent. I know that AD is congruent to CD, right? Because D is right in the middle. I know that these parts are congruent. And then finally, we're going to mark right here. These share a side. BD is the same side for both triangles, so we can just mark it right there. All right, so we marked our triangle. Now we're going to write down our T-chart. So you draw your T-chart, you put evidence and reason. I don't know why that. All right, so what's our evidence? We just write exactly what we know. We know that, well, let's see, our first thing right here, we know AD is congruent to DC. All right. I know that ADB, angle ADB, is congruent to angle BDC. And I know that BD, this is the hard one, don't forget this, BD is congruent to BD. Right? This is the shared side. It's congruent to itself. All right? So those are my 3 pieces of information. Now I got to write my reasons down. How do I know these things are true? Well, this first one right here, okay? Sorry, AD is congruent to DC. That was the midpoint theorem, all right? And that we just write, we know that that's congruent because a midpoint divides a line into 2 congruent segments. All right? Write that down. I got to erase it for more room. But a midpoint divides a line into 2 congruent segments. So you should be seeing here that in the reasons, all we're doing is actually taking that reason, all right, the reason that we see here, and we're just writing it in there. So you memorize this. You have to memorize. A midpoint divides a line into 2 congruent segments. All you have to do is write that in there. Okay, that's your reason. A midpoint divides a line into 2 congruent segments. You write it directly in there. All right, let me make a little room for myself. All right. And I'll just to write the whole thing. Don't be lazy about it. I'm just going to midpoint. Okay, and you know what goes next. The second part is angle ADB is congruent to angle BDC. And this is the perpendicular angle theorem, all right? So there's a long thing, but you have to write the whole thing in. And basically it says that 90-degree angles are always congruent, all right? Now you have to write the whole thing in here. Of course, I don't have room, but what we'd want to write is right over here. Perpendicular lines create 90-degree angles, and all 90-degree angles are congruent. That's what needs to go right here. That's your reason. And finally, BD is congruent to BD. And this is reflexive property. Sides are congruent to itself. All right? So you're just writing those three things, how you know everything, and then finally you write your conclusion. So I know that these two triangles are congruent. Triangle ABD is congruent to triangle CBD. All right, we proved this true because of side angle side. Side angle side congruence. All right, the last one I actually want you to try by yourself. All right, I want you to try this whole thing by yourself, draw everything out, and then check your answer, okay? I'll come back in a second. Pause the video now. Pause it. All right, if you were paying attention, this is what it should look like, all right? So, you should have marked E is congruent to C because those both created 90-degree angles, right? We know that AE is congruent to ED. That makes a 90-degree angle here and here. We know that D is the midpoint of EC, so that cuts ED and DC into two congruent parts, right? This cut it into two congruent parts. And finally, it's given to us that ADE is congruent to BD, which is these angles here. All right, so we got our evidence. This is angle side angle congruence. Now we have to write our proof. Well, we wrote down all our information. E is congruent to C. ED is congruent to DC. And ADE is congruent to BDC, which is given right here. And the hard part was writing our theorems, all right, our reasons. Well, we know E is congruent to C because of the perpendicular angle theorem. And you should have written out everything right here, okay? I don't have enough room, so I just wrote perpendicular theorem. But what you should be writing is this whole sentence right here, the whole thing. Perpendicular lines create 90-degree angles, and all 90-degree angles are congruent. All right? That needs to be written there if you're doing your proof well. The second part was the midpoint theorem. That's how you knew that. All right? The midpoint theorem is that, well, you should write the whole thing here. That, you go to your midpoint theorem, memorize this. A midpoint divides a line segment into two congruent segments. All right? And then finally, AD is congruent to BDC. Well, that was just given to us. And finally, you wrote down your conclusion. Triangle AED is congruent to triangle BDC, and that's angle side angle congruence. All right, that is a hell of a lesson. Let me know if you have any questions about it. And remember, guys, tell your mama, I'm going to learn this, and I'm going to get it, and I'm going to show you. It's not that bad. All right, peace, guys.